Hey, welcome. In this session, we're going to be talking about applying Kubernetes app development best practices. We're going to talk about what are the best practices, and then we're going to give a demo on how we use Google Cloud Dev tools to implement them. First, we'd like to introduce ourselves. I'm Kelsey Krippaehne. I'm a developer relations engineer at Google.
And I'm Abby Carey, a developer advocate for Google Cloud's developer experiences.
So, as with any type of development, following best practices when working with Kubernetes can save you time and unnecessary frustration. You may have to write lots of YAML configuration files, so unless you're a YAML expert, you'll want to have authoring support so that you don't have to constantly look up what property takes what fields or memorize the basic components of a service. For local Kubernetes development, you don't need to replicate your production cluster, but it's important to have a cluster for local dev that's configured in a way that ensures that what you're building will be compatible with the production cluster. Inspecting logs. Using commands like kubectl logs to inspect pods and services works okay, but trying to parse logs this way can be a pain, especially for beginners. A tailored logging interface is a more efficient way to get the info you're looking for. Debugging Kubernetes with CLI commands is cumbersome. Once again, using a tool that's tailored for Kubernetes debugging can save you from a lot of frustration. Excessive time to build and deploy. It's always a best practice to improve development velocity and not get stuck in a lengthy build cycle on every change to the code base. And finally, it's a best practice to share best practices. If your team has specific policies for developing Kubernetes apps, those patterns should be accessible as project templates that your team can reuse to ensure conformity and to make it easy for new devs to onboard. So we're going to start implementing these best practices with Google's Cloud Code. Cloud Code is an IDE plugin that automates dev workflows for cloud native applications. You can see Cloud Code as sort of a bridge between you developing in your IDE and Google Cloud. It's bringing the cloud to you. Cloud Code is particularly helpful when developing with Kubernetes because it comes pre-installed with tools like Scaffold, Minikube, and the Cloud SDK. Scaffold is a command line tool that handles the workflow for building, pushing, and deploying your application. Cloud Code uses Scaffold behind the scenes, so it acts as sort of a user interface for the Scaffold CLI. Minikube sets up a local Kubernetes cluster. It's small but powerful and extremely beginner friendly. Cloud Code is available for VS Code and JetBrains IDEs like IntelliJ. You can also try out Cloud Code on Google's web based IDE, the Cloud Shell Editor. All of these tools, Cloud Code, Cloud Shell, Scaffold, and Minikube, are 100% free to use. And we encourage you, if you want to try it out right now, go ahead and install Cloud Code on your IDE or try it out in your web browser with this link to an interactive tutorial. So, we've talked about best practices and how it can be difficult to implement them. The question now is, how do these Google Cloud dev tools make it easy to incorporate best practices into your Kubernetes development workflow? First, you don't need to be a YAML expert in order to write functional Kubernetes resource manifests. Tools like Cloud Code that provide YAML snippets and autocompletes make it so that you can author entire Kubernetes manifests without looking at YAML documentation. You should be developing on a cluster that replicates your production cluster as much as possible to avoid issues when pushing to production. You can configure a Minikube cluster to quickly develop and test locally with no added cost. You can also use Scaffold to create distinct profiles for dev versus prod and incorporate customize and kept for even more powerful deployment workflows. As mentioned before, it's a good idea to use a dedicated logging tool that makes Kubernetes logs more accessible. With Cloud Code's new logging support, you can drill down into your containers and container builds and your deployment logs. And you'll see that in a minute in the demo. For debugging, sometimes print and log statements just aren't enough. It's useful to be able to step through the code. Cloud Code brings Kubernetes debugging into your IDE. It lets you do step by step debugging live in your Kubernetes cluster, locally and remotely, using the IDE's debugging interface that you're already familiar with. Having an automated local dev loop is a general best practice, and you can set up Kubernetes iterative development using Scaffold. Scaffold has a file sync functionality that prevents you from needing to rebuild and redeploy your containers on every little change. And finally, you can use a tool like Cloud Code's custom samples to create project templates or samples to easily distribute your team's best practices. With custom samples, you can have a reusable Kubernetes configured app that your team can access right from their IDE. And now I'll hand things over to Abby for a demo.
Thanks, Kelsey. Let's get into IntelliJ and see some of these best practices in action. To kick off this demo, I'll show how you can Kubernetify a non-Kubernetes application with Scaffold. I already have Cloud Code installed from the JetBrains Marketplace, which means Scaffold has been installed too, since it's a managed dependency. I'll use Scaffold's init generate manifest command to get this app working with Kubernetes in seconds. And I want to mention that this functionality will soon be added to Cloud Code's UI. You can view Cloud Code as a front end for Scaffold, which is a command line tool. And now Scaffold's going to prompt me to pick my builder. And for my front end, I will be building with build packs. And for my back end, I'll use the existing Docker file here. Scaffold looks at my application and determines what the Kubernetes resources are, and then it creates a deployment.yaml file for each one. And now that that's finished, I have manifests generated for my application and a scaffold.yaml file that specifies its build and deployment pipeline. We'll take a closer look at scaffold.yaml later. This application is ready for Kubernetes, but these manifests that were generated are starting points. You will likely want to customize them. Your organization may have certain naming patterns or file system layouts. In this case, this application needs some environment variables and labels for the front-end and back-end containers, and an additional Kubernetes resource to deploy a MongoDB service for our database. I've added a version of this application with these changes made to a custom samples Git repository. Cloud Code's custom samples feature allows your organization to easily distribute best practices by letting developers connect their IDEs to custom sample repos, which I've already done here. A team best practice is to have starter projects that are set up to fit your team's preferred configurations. When talking in the context of K8's development, this would include run configurations and certain YAML files. And my new ready-to-go sample is called Nextbook, so I'll create it. The Nextbook application is a basic Kubernetes app with a front-end and back-end service. We've kept this demo app simple to better demonstrate complex Kubernetes dev flows. It includes logic to read from and write to a database and displays the most recently added database entry. Let's take a look at the contents of this project. This project is configured to use Scaffold for both development and production workflows. That's all set up with this scaffold.yaml file. I've also set up run configurations in my idea folder. By committing these files to your project's repo, this enables any developer to run and develop your application the same way. This helps with onboarding in a team environment. Scaffold.yaml ties the container images we're going to build to the K8's resources we're going to deploy. Scaffold supports a number of container image builders like Docker, Gib, Co, and more. I've already set up my Scaffold file to build my backend with a Docker file and my front-end image with build packs. Build packs are a set of opinionated image builders that encode language-specific best practices for containerizing applications. They save you from having to write custom Docker files. Scaffold profiles are very powerful for separating configurations for different uses or environments, including build, test, and deployment configurations. I have two already set for development and production, which is a best practice. My dev profile applies development settings, which shouldn't be enabled in production. One of our new products, Google Cloud Deploy, leverages Scaffold profiles to gather configuration details for each target environment. I'll dig deeper into the Scaffold file as I go through this demo. Cloud Code automatically installs necessary tools like Scaffold, so we're ready to start working on this application. Cloud Code comes with a Kubernetes Explorer. This gives you a view of all your deployed K8's resources and is an excellent tool for operators. Looking closer at one of my existing clusters I've deployed to, I can explore my deployed resources and even shell into a running pod to run some commands. Cloud Code supports any conformant Kubernetes cluster, whether that's a local cluster like Minikube or K3D, or hosted by a cloud provider. Today, I'll be deploying this application to my GKE dev cluster. For this sample app, my run configurations are already defined so that any developer can run this application on IntelliJ the same way I would. I have two configurations, development and production. It's a best practice to tailor workflows for different contexts. Let's take a look at my development configuration. This is a Cloud Code Kubernetes configuration that I've built on. My container registry URL is already set, and this is needed because my scaffold.yaml doesn't specify an image repository, allowing developers to easily deploy to multiple locations. An example of this is if you have a personal dev repository and a production repository. My run configuration is set to run on my GKE dev cluster. The option to automatically rebuild and rerun turns on Scaffold's watch mode for iterative development. In the build deploy section, we already have a Scaffold file, so nothing needs to be done here. As a side note though, if you don't have a Scaffold file, this is the spot where you'd be prompted to initialize one with just a couple clicks. One last thing I want to touch on before running is that I have a deployment profile set named dev. Dev is one of my scaffold profiles that I already defined in scaffold.yaml. Looking at my scaffold.yaml file again, my dev profile specifies a Docker file target, dev, for my backend Docker file. Now, taking a look at my backend Docker file, you'll see that it's multi-staged. With my dev target set, running my configuration will build the base image along with the dev portion here, turning on my Flask backend's debug mode. And if the target were set to prod, which is for my production run configuration, my Flask debugger would be turned off in production mode. Now I'll focus on my dev cluster in the Kubernetes Explorer and run this with my development configuration. Right now, Cloud Code is building and pushing my container images to my cluster. Now that that's done, Cloud Code port forwards my cluster's services to my local machine, so all I have to do is click the link from my front end. You can also explicitly set up port forwarding for other resources like deployments or stateful sets in scaffold.yaml. Now let's take a look at this application. And this is my application running remotely on my GKE cluster. Everything is looking as expected, so I'll enter a new entry to the database and yep, my output box is displaying the latest entry. Deploying an app to a cluster generates a ton of logs. Building container images, deployments, spinning up pods, and the logs streaming from your containers all generate logs. Figuring out the best way to view all these logs can require running multiple kubectl commands. Cloud Code splits the logs up into easily selectable sections. This makes finding where errors occurred in your deployment process easy. Logs are also streamed for each container, letting you focus on different components of your application. So right now we're still running our application and Scaffold's watch mode is waiting for us to make changes. Now let's look at the YAML of our deployed application and see if we can make it better follow Kubernetes best practices. We don't have a readiness probe, and you should always have one so that Kubernetes knows when your app is ready to serve traffic. This gets us a step closer towards zero downtime deployments and higher availability. We're going to use Cloud Code's YAML authoring support to create this probe real quick. I'll go down to my container and press Control Space. And there's the option for a readiness probe. Now to add some parameters. I'll press Control Space again and pick TCP socket. My port is 8080. What other parameters do I need though? Hovering over readiness probe shows me a documentation, and I see that I have a couple more options. Now I'll add initial delay seconds, set to 5, and period seconds, set to 5. That's looking good. Now I'll save this file. Scaffold's watch mode just kicked off, and we're redeploying. And now it's done. Our readiness probe is ready. This whole rebuilding and redeploying process is pretty fast, but we can make it faster, and that is with file sync. By setting up Scaffold's file sync feature, you can copy over a local file that you've just edited with one in your deployed container in seconds. This avoids the need to rebuild, redeploy, and restart your corresponding pod on a file change, saving you local development time. To get file sync working with my backend's Docker file, a little extra configuration is needed. But to save a little time, I've already done that. I'm using inferred syncing when using my dev scaffold profile. This means that Scaffold will look at my Docker file to determine the location of where my edited files should be synced to. All I need to do is tell Scaffold what files to watch. I've added star.py so that any Python file in my backend that I edit will trigger a sync. My frontend automatically has file sync turned on because it's being built with build packs. This auto sync feature is specific to build packs. There are file type limitations when using build packs, but JavaScript is supported, so my front end syncing is good to go. File sync may require configuring your web framework to detect and respond to file changes. I'm using Flask's development mode to restart the app on a .py change. For compiled languages or frameworks that don't provide this support, you'll need to use an external file watcher like nodemon or watchexec. If you're building with build packs, watchexec is automatically configured. Now let's see if we can sync a backend Python file. To visually test this, I'll hardcode a new entry into the output text box that says, "This is syncing." Now I'll open my run window back up and save it. My logs are showing that a sync just finished, so let's check out my Kubernetes app now and give it a refresh. And there's that data I just set in there. With Scaffold's file syncing, locally iterating on deployed Kubernetes application is super fast. Now let's talk about debugging. There are a ton of ways to debug a Kubernetes application, but what if debugging it was as simple as debugging any application in your IDE? You should run and debug your applications in environments that closely mimic production, so why not remotely on a GKE cluster? I could also switch to using a local Minikube cluster to cut down on latency, but since we're already talking about GKE clusters, I'll stick with that. So now I'm going to try and debug my front-end's app.js file. And all I should need to do is place a breakpoint. I'll set it to trigger after I post a message. And now I'll kick off debugging with Cloud Code's debug mode. And once I've set my paths for my front end and back end containers, I can now open up my application and post a message to see if we can trigger this breakpoint. And there we go. I'm now remotely debugging my application on my GKE cluster right from my IDE. I'll just step through the code a couple times and then finish running it. Super simple. It's good practice to add tests for your container image, and Scaffold supports running tests. For the last part of this demo, I'm going to run container structure tests with Scaffold. Container structure tests validate the structure of your container image, can check command outputs, and verify file content and metadata. Here we have test files for the backend and front-end containers. These files are written in YAML, but you can also use JSON. In the backend, I'm checking that Python is installed and that the requirements file exists in the container. In the front end, I'm testing to make sure I don't have any comments that include XXX left in my code, because I definitely don't want to push those into production. So my tests are written. Now let's go over to scaffold.yaml. In my prod profile, I've configured Scaffold to run the container tests. Now, after Scaffold builds the image, it'll run the tests before deploying to the cluster. I'll switch to my production run configuration and see if these tests pass. Looks like one of my tests didn't pass. Let's take a closer look. So my backend container test passed, but it looks like my front-end container has a comment that's causing this to fail. I'll go fix that right now. I'll delete this comment here and give it a run one more time. And everything passed this time. This application is now ready for production thanks to Google Cloud's dev tools like Cloud Code and Scaffold. Thanks for following along with us today. And if you want to check out the demo we used, you can find it on GitHub. To try these tools out yourself and maybe with your team, install Cloud Code from your IDE's marketplace. And finally, we encourage you to join the conversation at Cloud Code Slack channel. And on behalf of Kelsey and I, thank you again and enjoy the rest of Next.